Alright, in this video we're going to start with magnetism. When you cut a magnet in two pieces, we're down at the bottom of the page. When you cut a magnet in two pieces, you're left with two magnets, each with their own south and north pole. So cutting it in half just makes two magnets out of it. Let's use a different color so it shows up. True, false. Eventually, when a magnet is cut into small enough pieces, you have individual north and south poles. False. They always come as pairs. Three most common magnetic materials: iron, nickel, the element, not the coin, and cobalt. Atomic magnetic domains are aligned in strong magnetic materials. That's the whole purpose for making magnets. Describe the shape of a field around a magnet. So draw a magnet. Bar magnets are always nice. South, north, and it comes out of the north and into the south pole. So make sure you're drawing some vectors on these things, because forces are vectors, magnetic fields are vectors. Having a hard time squeezing some arrows in here. So out of the North Pole, in at the South Pole. Ready for next page? All right, the north pointing needle on a compass is pointing towards a South Pole. Opposites attract, and the compass itself is actually a little tiny magnet. Which pairs of magnetic poles attract? The opposites attract, just like for charges. And the like repel. So north repels north, south repels south. North is attracted to south. The force exerted by a magnet, how's it going to change as the distance from the magnet increases? We know that that one decreases. It's proportional. You can see the equation on your card. Force on a moving charge is a maximum when it's perpendicular to the magnet field, and it goes to zero when it's parallel. If the amount of charge, velocity, and field strength are each doubled, the force on the moving particle is increased by a factor of, since F equals BQV, if I double each of them, two more here, ooh, it's an ugly looking two more here and two more here, 2 times 2 times 2, gives me a factor of 8. Magnetic field strength is measured in Tesla. Big T. If a 3 Coulomb charge is moving with a velocity of 2 meters per second in a 4 Tesla magnetic field, find the force. We're going to use that BQV, and for space reasons, we're going to do 4 Tesla times 3 coulombs times 2 meters per second, so that we end up with 12 times 2, 24, and these are newtons because it's a force. Magnetic field strength generated by a current carrying wire changes as we get further from the wire, and that is going to be decreases, directly and inversely proportional, right? Let's see, calculate using F equals Bill. If we double the current, the length of the wire, and the field strength, then we get 2 more of current, we get 2 more of the length, and we get 2 more of the magnetic field, so a total of 8. Force on the current carrying wire is maximum when it's perpendicular, and it goes to 0 when it's parallel. That's why we're using the right-hand rule, right? Everything's at 90 degrees. That gives us our maximum force. 3 amp current moving in a 4 centimeter long wire, velocity of 2 meters per second in a 4 Tesla magnetic field, and I'm already worried about my centimeters. Got to be in meters. So 0.04. So I want to use F equals Bill. And I have B is 4 Tesla, I is 3 amps, and L is 0.04, and I don't need the 4 meters per second piece, so you can just ignore that. And when I do the math, I end up at 0.48. And these are newtons because they're forces. That's an awful looking N. Love working with this pen. There we go. Circle all the elements needed to make an electromagnet. For sure you're going to need a wire and a battery. It's nice to have an iron core, but it's technically not required, just not going to be a very strong magnet without it. So to increase the magnetic strength, increase the number of coils, increase the current, or add an iron bar, iron core, whichever way you want to think of it. Changing blank field will create a current. So let's change the magnetic field to induce the current or create the current. Motors transform electrical energy into mechanical energy, energy of motion, kinetic energy if you like that one better. Generators go the other way. They take kinetic energy, mechanical input, and they turn it into electrical energy. Both require a complete circuit and a magnet, and one provides the force to make electricity, the other one you use electricity to make the force. Electric field does not exert a force on a current carrying wire, but a magnetic field does. Next page. Last page of the packet, up to modern physics. Describe wave-particle duality. The photoelectric effect is proof that light acts like a particle. Interference, that's light acting like a wave. Water waves interfere with each other. Sound waves do. Wave-like behavior, interference, and diffraction. Current in the photoelectric effect increases as the intensity or the brightness of the light increases. And I'm just going to put brightness up here because that line is not very long. And the energy of the photons increases with the frequency of the light. Oh, and now we're on to radioactivity. Half-life of 10 minutes. So I'm going to put this down at the bottom. I'm going to pause for a minute to build the table. So you can see I've set up the table, time versus amount. At time 0, I have 32 grams. That's my initial. In 10 minutes, and then 20 minutes, and then 30 minutes, that's where I want to get to. Every time the time increases by the half-life amount, the 10 minutes, how much I have drops in half. So 16, 8, 4 grams. So I should have 4 grams after 30 minutes. On to the next one. Half-life of 10 minutes again. If we have 32 grams left after 40 minutes, how much did we initially have? So I've got a time of 0, 10, 20, 30, 40 minutes. Those are all my half-lives. Every 10 minutes, I go in half. So if I have 32 grams at 40 minutes, I had to have had 64 here, 128 here, 256 here, so 512 grams to start with. Another half-life. Whoop, there's the bell. I'll finish this in a moment. All right, let's see how fast I am. So every 10 minutes it's going to drop in half, and I want to know what time it's going to be when I have 32 grams. So 128, 64, 32, so 10 minutes, 20 minutes. Time elapsed should be 30 minutes. Uranium decays into smaller particles. That would be fission. Think of Alka-Seltzer fizzing, coming apart. Hydrogen nuclei. Make helium, that's fusion. Weakest form of decay. Alpha can be stopped by our skin, and that's a helium nuclei. Mass of 4, atomic number 2. Next weakest, beta. That's going to be either an electron or a positron, so 0 and -1, or 0 and +1. And the very last one, strongest, that one's gamma. That's just a photon or a wave of light, depending upon which way you like to think of it. You're all done with your review packet. Thanks.